In this video, we want to look at the graphs of sine and cosine. We are not going to look at all the trig functions today. We'll eventually get there, but today we are just going to look at the graphs of sine and cosine. Now, before we start graphing sine and cosine, we first need to talk about our graph paper. So this is our graph trig paper, and I've blown this up. You have this in front of you. But the way the graph trig paper works is, first, when we graph, we always graph in radians. And you will see why we do that with this paper here. Now, and the problem with graphing is trying to get our scale correct for our graphs. So if we look at this graph paper, you can easily see on the y-axis that this goes by a half. 0.5, 1, 1.5, 2, 2.5, and 3, and so forth. So the y scale is 0.5. Now, if we look at the x scale, it's a little different. You will notice it goes pi over 6, pi over 3, pi over 2. Now, as we go forward and we look at these, we will not have all of these marked. Here is what it's going to look like eventually. You can just see it has the pi over 2, pi, 3 pi over 2, and so forth. It doesn't have every single line. But if I put every single line, it looks like this. So what we're really looking at, if we go back to our unit circle, is we are graphing 0, pi over 6, pi over 3, 90. 2 pi over 3, 5 pi over 6, and pi, and so forth. So we're kind of graphing like every 30 degrees. We're skipping the pi over 4s and so forth. So when we look at our graph paper, as I said, our y scale is 0.5. And our x scale is pi over 6. Pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. Like every 30 degrees, but in radians. Now, if we look at that, if we would go to our calculator and we would look at pi divided by 6, we can see that we get 0.52. So really, our scale here is 0.52. So what this does is this graph paper, basically our x and y scale are the same, close enough for our graphing by hand. So here, this would be 1.054, but basically we treat that as 1. We treat this as 2. We would treat this as kind of like 3. Yes, it's pi, 3.1415, so forth. But if you're talking about, put a dot on your graph at 3, that's in the same range, ballpark. So when we do this scale on our trig graph paper, we are going to go by 1/2. Now, with our angles, that's very odd. We don't really talk about our angles going by 1/2. We may say by pi over 6. That's really close to 1/2. So if you want in the back of your mind, kind of our different language thing here, if you want to think about it in the back of your mind, each line on our graph paper for the x coordinate goes by like 30 degrees, or pi over 6. On the y coordinate, it goes by 1/2. Now, if we want to graph sine, and you may want to get out your unit circle, because I'm just going to go around these points fairly quickly around the unit circle, and you say, the sine of pi over 6 is 1/2, the sine of pi over 3 is square root of 3 over 2, the sine of pi over 2 is 1, and so forth. So we're going to want to put these on our graph, but let's go ahead and put these points on our graph. So we have sine starts at 0. At pi over 6, it is at 1/2. Pi over 3, it's at square root of 3 over 2. And if we kind of just learn what that is, square root of 3 divided by 2, so we have that in our head, is about 0.866. So when we go here, pi over 3 is 0.866. That's about right here. Pi over 2 is 1. 2 pi over 3, 0.866. 5 pi over 6 is 1/2. Pi is 1. 7 pi over 6 is negative 1/2. Here, 0.87, 0.1, negative 1, 0.87, and we just keep going, and you get all of these. So if we connected the dots, you kind of like are unwinding your circle around that. But just like a unit circle, you can keep going. So we could go again. 1/2, 0.866, 1, 0.866, 1/2, 0, 1, negative 1/2, negative 0.866, negative 1, negative 0.816, negative 1/2. And this goes, this sine curve, this sine wave goes forever. It also goes backwards, like this. So as you draw our sine curve, we want to try to make them curved. You want to try to go through these points and make them curved. I don't want to see you just draw straight lines, right? We want to try to curve these. Now, to help us to graph this, we're going to use something that I call the 5 key points. These are the points that we use to help us graph sine correctly. And our 5 key points are: where does sine start? 0. Where does sine end? Now, when we talk about sine ending, we're talking about one wave. Okay? When you look at sine, sine has one wave. After that, it just starts over. So if you consider, for a second, let me switch my, if you consider this one sine wave right there. Now, if I would take that wave, it just repeats down here. It just repeats back here. And if this went here and again, so this is our one sine wave. What this is called, this one sine wave, is known as one period. And we'll talk more about that in a second. But that is one period of sine. So for right now, we only want to graph one period. Because if you can get that one period correct, you're just going to repeat that over and over and over and over. So first, our 5 key points then again. Sine starts at 0. It ends at 2 pi. That's how long one period is equal to. It is equal to 2 pi, one time around the unit circle. Next, in the middle, our next key point. In the middle, it is 0. In the middle of the first half, it is at 1. In the middle of the second half, it is at negative 1. So those 5 key points are what we're going to graph and try to get in the right spot. Then we can connect the dots. Let's look at cosine. Look at the kind of the same idea with cosine. Cosine, if we go back to our unit circle, cosine is the x-coordinates. So we're going to be going around and looking at the x-coordinates. So cosine doesn't start at 0 like sine does. It starts at 1. And then it goes 0.86, 1/2, 0, negative 1/2, negative 0.86, negative 1, negative 0.86, 1/2, 0, 1/2, 0.86, 1. So there is one period of cosine. But once again, this continues to go forever like that. Or it goes this way like that. So our one period of cosine is just this part right here from where it starts to 2 pi. So let me do something here. All right. So cosine is going to have its own 5 key points. Cosine starts at 0. Excuse me, cosine, I said that wrong. Cosine starts at 1, and then at 2 pi, cosine's also at 1. Halfway in the middle, it is at -1. In the middle of the first half, it is at 0. In the middle of the second half, it is at 0. So those are the 5 key points of cosine. Now, you will notice going around this unit circle, going around these points on our unit circle, these special triangles, you'll notice we're getting a lot of the same values. And you can kind of see, if I take this graph of cosine and I just shift it over a little bit, that's sine. So cosine, sine, cosine, sine, cosine, sine, cosine, sine, cosine, sine. So a big part of these graphs is knowing where they start. So if you know cosine starts at 1, now you just do the same graph. If you're like sine starts at 0, you get to 0. It's basically the same graph. So once you get the starting point right, you just continue the wave as you go across. Okay, so very similar, obviously if we go back, now that's negative signs flipped over the axis and so forth, but our basic, there is cosine, there is sine, there is cosine, there is sine, right? All right, so what we want to do is we want to transform those basic shapes. Now, to help us understand how to do that, we're going to look at graphing these on the calculator. Okay, so here's what we want to do, and I'm just going to kind of do these here since it's a video. If I go to my calculator and I graph sine of x. Now I'm in radians. I can do, there is a special 7 for trig, and there's my sine. So there you can see sine starts at 0 and goes through. Now, the question becomes, what happens if I put a 3 here? How does that change my graph? That's what we want to talk about here. Okay, so how does putting a 3 in front change my graph? What happens is I get that. So by putting the 3 all in front, all it did is it took the peaks and pulled them up to 3, and took the valleys and pulled them down to -3. Where it was 0 didn't change. Still starts at 0, still ends at 0, still 0 in the middle. The first half of the middle, it's now at 3 instead of 1. So by putting this number in front, all it's going to do is stretch my graph. Now, if we happen, just to show you what happens if we put some other things in front, if we do a 0.5 in front, now instead of stretching the peaks, it like pushes them down. They don't go as high. And if we put a negative in front, let's put -2 sine, what this is going to do is it just flips it over. The peaks become the valleys, and this also stretches it to 2. So the first thing we want to talk about with our graphs is this number in front. And this number in front is called the amplitude. This changes the amplitude, which is the peaks and the valleys. How high the peaks and the valleys go. So if I want to graph 2 cosine, what we need to do is we have to know those basic shape, those 5 key points of cosine. And we know cosine starts at 1, but because our amplitude is 2, cosine is going to start at 2. Now, where cosine starts at 2, it's also going to end at 2. Halfway in the middle, it's at -2. There are 5 key points. Halfway in the middle of the front half, it's at 0. Halfway in the middle of the second half, it's at 0. And then now we're going to graph this by trying to do the best we can to draw our curved lines through our cosine. We are only going to graph one period, okay, because we know we could take that shape. If we had to graph more, we could take this basic shape and then, it's not connected. We could just redo this and go further, right? And there it goes forever, but we don't really worry about that. We are only going to graph one period, start and stop, because once we get to there, we can repeat it. Try another one. -3 sine. So sine normally starts at 0, still does, ends at 2 pi. In the middle, it is at 0. Understanding those 5 key points. In the middle here, normally it'd be at a peak, but because it's negative, it flips it over and it becomes a valley. Here is normally a valley, it's got flipped over and is at a peak. Now, we connect our dots with our curved lines, and that's not great, but you can get the idea. Okay? So that is how we change the amplitude. It's this number in front. The second thing we want to talk about is what happens if we put a number here. So let's go back here, and let's change this to sine of 2x. And see what this does to our graph. If I graph this, it does that. Now, there's 2 ways to think about this. The one way to think about this is by putting that 2 there in front of the x. The length of my one wave or my one period is half of what it was before. So now my wave just goes from here to here. It's half as long. Another way to think about it is in the length I normally have 1, I now have 2 waves. So however you think about it, that would work. Now, if we go put a bigger number here, let's say 4. Now, in the time of 1 wave, I have 1, 2, 3, 4. One way to think about it. And if I would make this smaller, let's say I put a 0.5x right there, what that does is it kind of stretches it out. Now I only have half of a wave in the same distance. So that kind of helps you to visualize what this number does. And what this does is it's a period change for sine and cosine. Okay, so period of sine and cosine is 2 pi, as I talked about. Sine starts here, ends here, 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 here. So when we change the period, what we are doing is we are changing how long until the graph or the wave starts over. Okay, so let's look at some just kind of general graphs to kind of see how this works. Let's say we have this. This is not any trig function, but to kind of help you visualize what we're talking about here. This part right here is one period. This graph just repeats this shape over and over again. 1, then there's another period, and it starts again. So this graph is periodic. Just does the same thing over and over. Let's look at some other examples here. We want to try to figure out what is the period. If you look at this one, and I think the easiest way to do this is start at the origin and then just draw your graph, trace over your graph, and when do you kind of not get to the same spot, but kind of start over? Here, right there. So my period is 2 pi. Here, I go down, up, right here. I am starting over for that graph. My period is 4. Here, when do I start over? I go up, down, right there. I am now starting over, so my period is 2. Here, start here, up, level off, down, level up, and I get back to here. I am starting over, so my period is 6. That's the idea of what it means to be periodic. When does a graph start over? Okay, and we find that period by this number in front of the x. Now, as I showed before, that changed how we graphed it. But if we want to actually find the period, we are going to take that b in our graph and divide it by our normal period of 2 pi. So let me show you how this works. So let's say we want to graph y equals sine of 2x. Now, first, we mentioned it since we've already looked at it. Our amplitude is the number in front of the sine, which is just a 1. So that means our normal amplitude, peaks and valleys are the same. Our period is 2 pi divided by our b. And our b here is 2. So 2 pi divided by 2 is pi. So how do we graph that? So what the period tells us is where the graph ends. So sine starts at 0. Now, instead of ending at 2 pi, it ends at pi. Now we're coming back to our 5 key points. Halfway in the middle, it's at 0. Halfway in the middle here, it's at its amplitude, which is just 1. Halfway in the middle here, it's at its amplitude, which is -1. So here is our graph. Okay. So another one. Cosine of x over 2. Once again, our amplitude is 1, which is nice. Our peaks and valleys are at 1. And to find our period, we take 2 pi divided by the number in front of the x. Now, it looks a little unusual here, but really, this is the same as 1/2 times x. So this is 1/2. So that means we're going to divide by 1/2, but dividing by 1/2 is the same as flipping and multiplying. So we get 4 pi. So how do we graph that? Well, cosine normally starts at 1, so it still starts at 1. Normally it ends at 2 pi. Now it ends all the way at 4 pi. In the middle, it's at -1. In the middle of the first half, it's at 0. Middle of the second half, it's at 0. And here is our graph. If I can get this to draw somewhat like that. All right, let's look at one more. Y equals 2 sine of pi x. So now we got both, right? So we have our amplitude is 2, and our period is 2 pi over pi. Well, that simplifies down to just 2. So, to graph sine. Sine starts at 0. No different. Okay? My amplitude is 2, but where does it end? Where is 2 on the x-axis? We're going back to the unit circle. Where is 2? 2 is not an angle on our unit circle. But remember, these go by a half. Half, 1, 1.5. This is basically 2. Now, it's off a little bit. It's 2 pi over 3, but that's basically 2 for our graph. Now, our 5 key points for sine. In the middle, it's 0. In the middle, it's at its peak, which my amplitude is 2, so my peak is 2. My valley is at 2. So I get these graph where I have this high peak that's very skinny, and we can talk about frequency and the wavelength and all those science terms, but for today, we're just looking at the amplitude and the period. How high are the peaks and valleys, and how long before the graph starts over. All right, you are now able to do the homework on trig graphs.